6.1 is on statements. We're starting the unit on logic, but 6.1 is just statements. A statement is a declaration, and you're going to be able to tell is if it may be true or false. Someone somewhere can prove if it's true or if it's false. That's what a declaration would be. That's what a statement is. Now notice they can't be both true and false at the same time. You'll see what I mean in a second. Example 0 says, which of these are statements? Part A, Mount McKinley is the tallest mountain in North America. Now, I don't know if that's true or false. Maybe you do. Maybe someone in the world knows if that's true or false. And if that's, whether that's true or that's false, somebody can tell me. And that is a statement. Part B, 15 minus 9 equals 10. Now, clearly that's not true, but who cares? It's false, so what? It's a statement. A statement can either be true or false. Part C, follow the yellow brick road. Not a statement. Can't prove that. That's not true nor false. Are we having fun yet? Well, that's a question. That's not a statement, but I can't prove it true or false. Now, the last one's kind of an interesting one. This sentence is false. When you read it, when you look at it, it looks like a declaration when you're thinking about English, but think about it. If this sentence is false, okay, if this is true, let's just assume that it's true. If it's true, then what it says is true. But wait, what it says is it's false, so it's true that this thing is false. Seems to be contradictory, right? So it must be false, right? So if it's false, then what it's saying is false. But it says it's false. So that would make it true. That can't work. Okay. Can't be both true and false at the same time. This is not a statement. All right. Question?
Can it be a question? Like it's always a question. It's always not a declaration.
Can you give me an example of that? The question was, can it be a question? Can it have a question mark and still also be a declaration? Can you give me an example? I can't think of one either. So I'm not sure. I'm going to go with probably not, but never say never. Maybe one of us can think of an example for that. Logical connectives. Look for these words. Look for and, or, not, and if, then. We're going to use those to form compound statements. Compound statements is one or more simple statements combined with logical connectives. It's going to say something like, Mount McKinley is the tallest mountain in North America, and 15 minus 9 equals 10. So we're just taking a couple of statements and combining them using these logical connectives. Component statement is just one part of it. It's the part before the and or the part after the or, whatever. So a compound statement, one or more statements combined with one of those connectives. Number 1, decide whether each statement is compound. Washington was the first U.S. president and Adams was his vice president. Well, yeah, it's got a statement, a logical connective, and another statement. So yes. Part B. If what you told me is true, then we are in great danger. Statement, what you told me is true. Statement, we are in great danger. The logical connective here is this if-then, an if-then statement. Part C. We drove across New Mexico toward a town named Truth or Consequences. So sometimes people will see this word or. Sometimes the word or is not a logical connective. That's not connecting two different statements. So that's not a logical connective. It's just the word or. This is not a compound statement. Part D, the money is not there. Not is one of our logical connectives. It might make more sense to look at it like this. There is money, and It's not there. A little bit easier to see, I think, that this is a compound statement. And oh yeah, part B, forgot to write the word yes, but yeah, that is. Next, we'll talk about negation. Negation is a way to make a true statement false or a false statement true. Number 2, give the negation of each statement. Part A, California is the most populous U.S. state. Well, all you'd have to do is add the word not in there. California is not the most populous U.S. state. It is not raining today. Well, let's just get rid of that and say it is raining today. Now, we could rewrite that, and on your homework, you will rewrite that, but I don't need to rewrite that on this video. Number 3, write the negation of each inequality. Well, if it's not greater than 11, then it must be less than or equal to 11. 4x plus 9y is less than or equal 36. If it's not less than or equal, then it must be greater than 36. So we're doing the negation. Now we need to talk about the symbols. So the symbols used in this book look like this, this, and this. These are really important symbols that you will need for and, or, and not. We're going to take sentences, and I don't want to write down all these sentences, so we're going to symbolize, and we're going to use symbols to abbreviate, and it's going to make life a lot easier, I think. Now, I have seen other books. We'll use a symbol that looks like this. Maybe you remember that from earlier in the year. That meant and. Other books looks kind of like a staple, but all three of those kind of say the same thing. Or I've seen it written like this. We talked about the union when we were talking about sets. Other books, it looks like this. All of those kind of mean the same thing, but this book will use the symbols shown in red. Not is just kind of like a squiggle. Number 4, let H represent my backpack is heavy and R represent it's going to rain. Write each symbolic statement in words. So you would need to notice that this symbol right here means and. The worst part about this section to me is all the writing. And we have to write all of this stuff out in words. But what that says is my backpack is heavy and it's going to rain. Weird thing to say, but that's what it says. Part B, this symbol we know means or, but this symbol is the negation. So we can read that as not if we want. So like, if I was just reading the symbols, I would say not H or R. That's how I'd read that. Not H or R. But if you think about it, we got to negate the statement H. So my backpack is not heavy or it's going to rain. Don't worry about if the statements make sense or not. That's a really weird thing to say, but we're not judging that kind of thing. Later on, we'll talk about if that's true or if that's false or whatever. But for now, just write down what it says. The next one does not say the same thing. The parentheses changes things slightly. And so you've still got this or, and you've still got this negation, but you have to kind of word it a little bit differently. It is not the case that that's how I handle the parentheses. It is not the case that my backpack is heavy or it's going to rain today. I don't know why I added the word today. It's not there. Yes?
So would it still be like correct if you said like it is not my backpack is not heavy or it's not going to rain?
Um, Good question. Question was, can we say my backpack is not heavy or it's not going to rain? That's what you said. And so what you're trying to do is distribute that negation over there, and that makes perfect sense for algebra. But we're going to find out, I think, in the next lesson that's not allowed. You can't actually do that. If you tried to say not H or not R, that's not going to mean the same thing. Okay, it doesn't quite logically match up. So great thought, great idea. It doesn't work that way, and we'll see that a little bit later when we talk about something called De Morgan's laws. All right, great question though. So this one, same thing. You can't really distribute the negation. So what we're going to say is it is not the case It is not the case that my backpack is heavy and it's going to rain. Let's move on. Truth table. Truth table is a table used in logic to display the truth value of a compound statement for every possible combination of truth values of its individual component statements. That's a lot of words for it's just a table with all of the true false values. So we're gonna start building tables, and the easiest one is to talk about the negation, or in other words, not P. So we're talking about P in this problem. You're going to start your table with each statement on the left side. And then what we want is we want the negation, so we're going to put not P on the right side of this table. On the left side, you want to go through and list every different possible thing that could happen. Well, if we're just talking about P, I don't know what P is. Maybe it's talking about my backpack is heavy or whatever the statement is. P could either be true or false. And so then we would go through for each row in this table and say, well, the negation, if it's not true, then it's false. And if it's not false, then it's true. We're going to see a lot more complicated truth tables than that, but that'll get us started. That's the negation. Conjunction and conveys the idea that both component statements are true. We can also do this with but. All right, the word but could potentially act the same as and. Your birthday is in July, but mine is tomorrow. Wouldn't that mean the same thing if that was an and? So sometimes you can play around with the wording, or sometimes whoever writes the sentence plays around with the wording, but in this case, that word but means the same thing as if we had used the word and. So let's let's look at the truth table for the conjunction and. The conjunction is and, could be but. So in this case, we've got two separate simple statements. We've got P, we've got Q. This complicates the matter a little bit. We want to talk about P and Q. We've got the statement P and Q. Remember the symbol for and. So in this case, there are more possibilities because both of these things could be true, or P could be true and Q could be false, or P could be false and Q could be true, or they both could be false. So in this case, there are 4 rows of our table. Now, this is going to be really important because we're going to do the same kind of deal over and over again. P and Q. In the first row, that's true and true. Well, if the first one's true and the second one is also true, then that makes this statement true. True and true is true. But you look at the second row, true and false. So the overall statement, if the first part is true and the second part is false, that makes the whole thing false. True and false is false. False and true, same thing. If one of the things is false, then the whole thing is false. And then at the bottom, false and false. Well, of course the statement's false. If both components are false, then the overall thing is false. And so we're concerned with that column in blue. The only way to make that statement true is if both components are true. True and true is true. That's the only way. Everything else is false. Questions on that? Number 5A. Let P represent 5 is greater than 3, and let Q represent 6 is less than 0. Find the truth value of P and Q. So think about it. This right here. Is that true or false? 5 is greater than 3. That's true. Look at this component. 6 is less than 0. Is that true or false? That's false. So if you look at your two individual components, what we've got is true and false. Well, what's the result? If one of them's true and the other one is false, then what's the statement would be 5 is greater than 3 and 6 is less than 0. Well, that's false. The only way to make that true is if both of those statements were true. Now, if we go back and look, what we just did was we're looking at the second row of that table. True and false is false. That was just one specific example. Part B, rewrite the following statement using the word and instead of the word but. I was not ready yesterday, but I am ready today. Well, that's easy. All we're doing is just changing that word to and. And I'm not going to make you recopy that, but that's what you would do. I was not ready yesterday, and I am ready today. I think it makes more sense to say the word but they both mean the same thing. Sometimes you'll see it and it'll be worded in a weird way, but those both mean the same thing. Disjunction, or, conveys one or the other or both. Disjunction, or. So now we want the truth table for P or Q. So again, left side, we're going to have our individual components. We've got P, we've got Q. And it's always going to be the same thing every single time, because either they can both be true, or P can be true and Q can be false, or P can be false and Q can be true, or both can be false. I would try to get in the habit of writing them in the same order every time. You could jumble that up and it wouldn't make a difference, but if you write it in the same order, I think you'll have an easier time. We want to do the disjunction the or statement, P or Q. And again, this is really important because this will come up a lot. If we've got true or true, either this is true or this is true, then the whole statement is true. Makes sense? But then the next one, either the first one's true or the second one's false. True or false. Well, that's true because you don't have to do them both. You don't have to have both of them true at the same time. It's an either or, right? Either one or the other or both. It's one or the other or both. So if one of them's true, then it's true. False or true is true. But false or false is false. If both of them are false, then the overall or statement is false. So that row right there, that column is really important. Number 6, suppose P is false, Q is true, and R is false. What is the truth value of the compound statement not P and Q or not R? So don't try to do all of this at once. Let's just break it down. P was false, right? So let's say not false and Q is true or not R is false, so not false. So think about it that way. We can kind of substitute in the truth values for each individual component and then do like an order of operations problem. Over here, not false must be true right here, right? If it's not false, then it's true. And inside the parentheses, we've got true is true or not false. Not false must be true right there. And so again, think about it as order of operations. You look at the parentheses, true or true is true. And so then I have true and true. True and true is true. And so what that tells me is that overall statement, I know not P and Q or not R, the overall value of that statement is true. Number 7, same kind of deal. Let P represent the statement 3 is greater than 2, Q represent 5 is less than 4, and R represent 3 is less than 8. Decide whether the following statements are true or false. Well, first thing I would do is go through and assign values. 3 is greater than 2. Well, that's true. 5 is less than 4. It's false. 3 is less than 8 is true. So I can see each individual truth value. Now, I know you're going to be able to do some of this in your head, but resist that urge. Make sure you show a little bit of work here. Not P. So that would be what? Not true. And not Q. That's going to be not false. So just treat it like an order of operations problem. Not true. That must be false. And not false must be true. We've got false and true equals what? False and true is false. It is not the case that P and Q. So we've got not P was true and Q was false. Look like that. Just substitute in the individual truth values and do an order of operations problem. Inside the parentheses, we've got true and false. Well, true and false is false. Then we have to negate that. Not false is true. And then over here, not P is true. And R is true, or not Q is false, and not P is true. That's where I would start that. So then look inside each individual parentheses there. I've got not true, that's false and true. Or we look in the other parentheses, not false must be true, and not true is false. Continuing, false and true. False and true is false. Or true and false is false. False or false is false.